So we're at the point where we have the generating function, and we're at the point where we're solving this y double prime minus xy was equal to 0. All right? And in the previous video, we got to the trivial solution. We got to the fact that c2 equals negative c naught. All right? And we're at the point where we have the generating function. And what we're going to do is we're going to try to guess a formula for this. All right? So here's what we're going to do. We have our k, which is equal to 0, or k starts at 0. So we have our first value of k, and then we're going to have c sub k plus 3. So we have k, and we're going to have ck plus 3, all right, which is going to be equal to our opposite ck minus 2ck plus 1 divided by k plus 3k plus 2. So let's now substitute and generate. When k is equal to 0, we have c3 is going to be equal to the opposite of c naught minus 2. I'm sorry, that's not an opposite of ck. That's a typo there, or righto. It's just regular c naught, so copy error, sorry about that, minus 2c1 divided by 3 times 2. And we're going to hold on to that just in case we're able to simplify that any further. Another way we can write this is we can write this as c naught over 6 minus c1 over 3 if we wanted to break it up into two smaller fractions. And we'll see that there might be a benefit to that. Now, when k is 1, we know that we're going to get a c4, which is going to be c1 minus 2 c2 divided by 4 times 3. However, we know a little something about c1 and we know a little something about c2. Right? So we remember that c1 is just going to be, our c1 is just c1, so we don't really know anything about it. But we do know that c2, remember that c2 is the opposite of c naught. All right, and you might remember we found that out all the way back here. Remember when we took off those summons from the series and we were able to figure that out. All right, so another way to rewrite this is we can rewrite this as c1 plus c naught over 12, or a third way to write this, c1 over 12 plus c naught over 6. All right, so now here's where it's going to get a little bit interesting. Right? C5, that's going to be equal to, remember we go up to whatever k is, C2 minus 2 C3s divided by 5 times 4. Right? For us, we already know what C2 is. Okay, remember C2 is just the opposite of C naught. We also know what C3 is. C3 is this quantity. All right, so we can rewrite this, if we choose to, and we do choose to, as opposite C naught minus 2 C naught over 6 minus C1 over 3. And that's all divided by 20. Right. And now we have an expression that we can simplify even further. Now notice that we have a negative 1c1, and then this is just going to turn into a negative 1/3 c naught. All right, so we have negative c naught, and then we have negative 1/3 c naught. So if we add those together, that's going to be equal to negative 4/3 c naught. Okay, so all I did was I just combined this and then the negative 1/3. And then we're going to have a positive 2/3 of C1. All right, so now you can see where this is going to get a little bit interesting, because now we're going to keep doing, or we're going to keep simplifying in terms of both C0 and C1. And when we get our recurrence relations, that's how we're going to simplify this. Okay, so let's just do one more of these, because if we do that, that'll give us up to the 6th power. And that gives us at least 3 terms for each of our different polynomials. All right, so the third term, and that's going to be C6, and that's going to be C sub 3 minus 2 C sub 4 divided by 6 times 5. We're going to go back and we recall that C3 is this C naught over 6 minus C1 over 3. So that's going to be C naught over 6 minus C1 over 3 minus 2 of C4. This is a 4. Make it look right. All right, so that way you can all see. And C4, if we go back here, C1 over 12, C naught over 6. And that's still all over 30. And so now we can simplify this. Right? So we have C naught over 6, and then we also have negative 2 C naught over 6. So that's actually just going to turn into a negative C naught over 6 over 30. So it's negative C naught over 6 over 30. All right, and by the way, this is C6. So we see it's starting to get really ugly. I may have forgotten up here, by the way, to divide by this 20. So let me rewrite this one while we're up here. Yeah, that wouldn't be good. And that's going to give us, if we divide that out by 20, that's going to give us negative 1/15 C naught plus 1 over 45 C1, just by simplifying. All right, because this will turn into 2 over 60, so that should be, yeah, that should be, excuse me, this should be 1/30. All right, so just to make sure. Okay, so now that we've cleaned that up, now we're going to go ahead and go back down here. So remember, we figured out the C naughts. We're going to combine the C1 terms. Right, so this just becomes negative C1 over 3 minus C1 over 6. So we have C1 over 3, negative C1 over 3 minus C1 over 6. So that's going to turn into negative 3/6 or negative 1/2. So when we add those together, so that'll be negative C1 over 2 over 30. And mercifully, we can just say that this is going to be negative C naught over 180 plus C1 over 60. All right. Now, I think we probably have enough terms to be able to go through and say that we can write out the solution to this. All right. So when we write the solution, remember, all of these C's are the coefficients of the powers. Okay. So when we go back, we're going to write our solution y as C0 plus C1x. Okay, because remember, it's a power series. But it's not just x, it's going to be x plus 2. All right, so that's the difference between what we looked at before and what we're looking at now. It's not centered about 0, it's centered about 2. So it's C naught x plus 2 to the 0 plus C1 x plus 2 to the first plus, now remember we had that C2 was equal to C naught negative. So this is going to be plus the opposite of C naught, x plus 2 squared. Now we're going to go to that third power, so we need to go up to C3. And remember, C3 is C naught over 6 minus C1 over 3. So this is going to be the coefficient that we have. So that's going to be C naught over 6, C1 over 3, quantity. And just to make sure I have the signs right, And then that's going to be x plus 2 to the third power plus, so we're going to look at C4. C4 is 12 and 6, so that's going to be C1 over 12 plus C0 over 6 times x plus 2 to the fourth power, fifth power, negative 1/15 C0 and 1/30 C1. Right, so that's going to be negative 1/15 C0 plus 1/30 C1. And that's going to be x plus 2 to the fifth. And mercifully, our last one is the one that we just got, the negative C0 over 180. Plus C1 over 60, and we're going to divide or multiply that by x plus 2 to the sixth power. And whatever that pattern is, which we don't really care about, that's just going to keep going on forever. All right, we can leave our solution like this. All right. Now, if we wanted to figure out what each of the solutions looks like, what we would have to do is we'd have to distribute, we're not going to do this, but we'd have to distribute C1 and C0 to each of the x plus 2's, and then from there we'd have to combine like terms, or we could just factor out the x plus 2 powers and kind of get a like term at that point. Suffice to say for us, this is probably going to be good enough. All right, and remember, the whole idea for us is just to be able to find some sort of polynomial to represent the solution. So we would need some sort of initial value to make this really happen, as well as the derivative of that initial value. All right, so that's how we can go about trying to find the series solution about a point other than 0. So try to watch this again if you got mixed up with some stuff. And then make sure you go through and practice a few of these so that way you can feel confident in doing them yourself.